Okay, so consider these oxyacids are those acids that contain oxygen will produce, by decomposition, we produce water and a molecular oxide that will depend on the oxidation state. Now, for this molecular oxide and the oxidation number calculation, you need to take into account two rules, okay? The first rule is hydrogen, okay? Hydrogen is plus 1, okay? That is going to be the first rule. And the second rule is about oxygen. Oxygen is minus 2, okay? Those are the two rules that you need to know for the molecular oxide part. Now, let's work with one example. Okay, this acid that you see in the whiteboard is an acid that is composed of hydrogen and a oxyanion C2O4 that is known as oxalate. So if I have to name this acid, it's going to be, because it ends in ATE, the name will be oxalic, and mandatorily the word acid. Okay, so we're going to decompose oxalic acid. So what is this going to be? Or what is going to result from here? Okay, the rule says oxyacids, it is an oxyacid because it has oxygen. Okay, so we can apply the rule. It says water. Oh, water, pretty simple. And it says a molecular oxide. Now this molecular oxide is going to be formed between, okay, between the element in the middle, well, the middle element, and because it says oxide, it's going to be plus oxygen. Okay, so the combination will be between them, the middle element and oxygen. So in here, the middle element is carbon. Okay, so we're going to focus on this. Since we're going to focus on the middle element, that means that that's the oxidation state that you need to calculate. So we say oxidation number calculation. Okay, oxalic acid is composed of two hydrogens because of these two right here. Okay, I have two hydrogens. It's composed of two carbons, those two carbons, and it's also composed of four oxygens. So we say 4 plus 4 oxygens. We need to equalize this to 0. So we say equal to 0. And now we start by applying the rules. Okay, remember the rules are here. The first rule is hydrogen plus 1, and the second rule is oxygen minus 2. So we're going to substitute by the numbers given in the rules. Okay, hydrogen plus 1, oxygen minus 2. So we say 2 hydrogen, which is 1, plus 2 carbons plus 4 oxygen, that is -2, equal to 0. Okay, I apply the rules for each, and then I multiply, so I get 2 times 1 is 2. This one I just copy it, and here 4 times -2 is going to give me -8. Okay, equalize to 0. Then I solve for the subtraction. 2 minus 8 gives me -6. So this gives me -6 plus 2c equals 0. The 6 is going to go to the other side. It is subtracting. When you send it to the other side, it will be adding. So you will have 2c equals 0 plus 6. You can get rid of the 0 already. And then this 2, that is multiplying carbon, is going to go to the other side by doing a division. Okay? So in the end, carbon will remain alone, and in the other side you will have +6 divided by 2. Or, well, I don't know how you guys it honestly. Or what you can do is divide by 2 each side of the equation. 2 and 2 will be cancelled, and C is going to be equal to the result of this division. 6 divided by 2 is +3. And with this you get the oxidation number of the middle element. Okay, sorry. Now I know all the oxidation states. I'm just going to write them here. +1, +3, -2. Those are the oxidation states. Now, how do I form the molecular oxide? Well, I'm going to do the procedure here. So according to what I wrote over here, the molecular oxide is made of the combination of middle element plus oxygen. So this middle element is carbon, okay? Carbon and oxygen. Now, we got already the oxidation state for carbon, which is +3, and you know the oxidation state of oxygen, that is -2. So you're going to combine them, okay? So in the end, you are going to have C3O -2, and you will crisscross the charges. So carbon will be followed by number 2, and oxygen will be followed by number 3. Okay, so this is what I'm going to get. C2O3. This is what we know as the molecular oxide. So I'm going to take it here so I can complete the equation. And now, what I have to do is checking if the equation is balanced.
It's already balanced.
Okay, it is already balanced. It is balanced because you have two carbons in the left, two in the right. You have two hydrogens in the left, two hydrogens in the right, and you have four oxygens in the left, and 1 plus 3, four oxygens in the right. So we say that this equation is already balanced. So you can see this procedure might be a little bit long, but if you follow the procedure the way I gave it to you, is going to be correct. Now, I want you to ask me something. I want you to ask me if there's something that you want me to explain again of this procedure.
I want to ask about the quiz. The quiz is going to be about the homework that we made last week, right?
Exactly. It's going to be exactly like the homework that you did last week. Okay? Only the three topics: decomposition of acids, oxides, and by electrolysis. And I will indicate in each problem what kind of decomposition you are doing. Besides, it's very easy to determine because oxides will have oxygen. Okay, they're going to be binary and they will have oxygen. Electrolysis, they're going to be salts most likely, and acids, well, you can have a structure of the acid. Always an acid is going to be involved. If you already if you haven't done that homework, please send me a message today after um, afternoon, okay? So I can I can send you a different link so you can do the homework for less points, of course. But at least you will practice. At least you will present your homework for less points, and you will practice for the quiz. Those exercises are very good for practice. Okay. A question about this exercise. Okay. Do you want me to explain another example about the acids? Or I continue with oxides and electrolysis?
Continue.
Okay, okay, oxides. Well, in the case of for oxides are going to be decomposed in the following way. Oxygen, oxygen gas. What do you have to know about oxygen gas?
Diatomic.
Exactly, that is diatomic. Okay, what else?
Another element.
This one is going to be uncombined. So they're going to split. That's all you need to know. They're going to split. And one of those products will naturally be oxygen gas. Okay? And whenever oxygen is alone, it's going to be diatomic. Remember, I sent you a picture of the 7 diatomic elements, the mnemonics. Have no fear of ice cold beer. So oxygen is the off part in the sentence, so that is going to help you a lot. Now let's try with an example. Here it's pretty simple, guys. All you need to know is that those elements are going to separate, are going to break down. Okay? Let's try with an example. Okay? This one pretty simple. The only reason that I know that it is an oxide is because it has oxygen. Okay? And because if you name it, it's going to be magnesium oxide. So now you have two reasons to know that's an oxide, because of oxygen and because of the name oxide. So magnesium oxide is going to break down into the metallic part, which is magnesium. It's going to be alone, magnesium alone, and oxygen gas. Oxygen gas, which is diatomic. Now, you might be thinking, Miss, but there you say oxygen gas goes before the another element. Both ways are going to be correct. Whether you write oxygen here or here, okay, it doesn't matter. What matters is that the product is actually good. So you can write it like that or like this, plus Mg. Oh my god, I'm so hungry. Doesn't matter, okay? Both are correct. Now, one thing to know is that this other element can be diatomic or not. To know
Okay.
if it is diatomic, just remember the phrase, okay? We have hydrogen, nitrogen, fluorine, oxygen, iodine. This is for chlorine, not carbon, chlorine, okay? And bromine. All of them are diatomic. Yes. Now, what you do after is checking that it is balanced. So as you can see, it's not balanced. So you balance them. You have 1 and 1 in the reactants. You have 1 and 2 in the products. So you place 2 over there. And my magnesium and oxygen are going to change. Okay. Now just to balance magnesium, put that 2 in front. And it will be balanced already. Some other times, um, you're gonna see that you have transition metals. For example, I can give you the equation, the decomposition equation in words. For example, I can say iron 3 oxide. How is this going to be decomposed? First, what you have to know is that you need to convert those words into a compound. Iron 3 is iron with a charge of +3, and oxide is oxygen with a charge of -2. So the first thing that you have to do is crisscrossing the charges to form the compound. This is the procedure that I already told you. This is what we know as compound formation. Okay, so this 2 now is part of iron, and the 3 now is part of oxygen. Okay, so the compound form actually is Fe2O3. And now we can say that we can get the product. So one product is going to be oxygen gas, O2, diatomic, always. These two, do not forget. If you forget it, will be incorrect. For sure, it will be wrong. Okay, so do not forget. Plus the other element, iron. Now, is iron diatomic?
No.
No. This F from here is just fluorine, not iron, okay? Okay, if it was fluorine, then yes. But no, this is iron, so you're going to write it like that. Uncombined, it doesn't have any substrate, okay? So what you do after is checking that it is balanced. As you can see, it's not. So you have to balance. You have 2 and 3. And in the product, you have 1 and 2 respectively. So you have to balance. How do we balance this? First, I put 2 in front of iron, and it's going to be balanced. Then, because I need to get 3 oxygens, by what number I need to multiply oxygen to get 3? By what number I need to multiply 2 to get 3?
1.5.
1.5. Okay? Now my oxygen is balanced, but I cannot leave this answer like this. I need to multiply all the reaction times 2. Okay? Guys, when you multiply times 2, don't leave me the answer like this. Okay? Eso no es una respuesta, chicos. You have to multiply times 2 and then write the final answer. Remember, here it's like having invisible 1. Entonces nos quedaría 1 times 2, 2 Fe2O3. 1.5 times 2 nos quedaría
3.
3. And then 2 times 2 gonna give us 4.
4.
Now this one is the final answer, so I put it in a box. Sorry, you're not seeing it. And now in the other part, what you have is electrolysis. I don't know if you have a doubt on this one. But in the case of electrolysis, they're going to break down into the individual elements, okay? So, in electrolysis, you know that is whenever we use electricity to break down compounds. in this procedure, salts, for example, are going to break down into the individual element, into the elements that are making up the compound. So, for example, if I have potassium sulfide, okay, that's a salt. It is a salt because I have a metal and a non-metal combined. This is going to break down into the individual elements. The first element that I have is potassium. Potassium, okay, remember the video, potassium plus the second element that is sulfur. Question, is sulfur diatomic?
No.
Guys, no, sulfur is not diatomic. I don't know why, but they think, my students usually think that sulfur is diatomic and they write a 2 right here. If you do that, it will be incorrect. Sulfur is not diatomic. Remember, these are the diatomic. Hydrogen, okay? Nitrogen, fluorine, oxygen, iodine, chlorine, bromine, not sulfur, okay? So this is going to be the product, as simple as that, and all you do after is balancing. Metals first, and then the non-metals. So all I have to do is placing 2 in front of K, and then my potassium is balanced. Remember, if you put 2 here, it's going to be incorrect, no matter if you know how to separate the compound. Let's try another example. Okay, this one. Calcium bromide. How is this going to break down? Just separate the elements. Okay?
Calcium plus bromine.
Calcium plus bromine. Is calcium diatomic?
No.
No.
Is bromine diatomic?
Yes.
Yes.
Do I need to balance?
No.
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 A simple vista, you can see it is already balanced. Okay, let's try this one. What is going to produce?
Beryllium and sulfur.
Beryllium and sulfur individually.
It's already balanced.
And it's already balanced. So you see, some of them are very simple, they will be already balanced. And some of them are also simple, but just taking into account that sometimes you're gonna need to know, not sometimes, all the time you need to know what are the diatomic elements. Okay? I'm going to write the remaining elements here. So as you can see, the quiz that is coming is very, very simple. Take advantage, get a good score. Everything is going to be just fine. So there you go. Please study for the quiz. Everything is going to be okay.
Thank you, Miss.
Okay.